All right. Welcome, everybody. It's so glad to have you all here. My name is Byron Minson. I am the Education and Outreach Coordinator with the Virginia Association of Soil and Water Conservation Districts. And I'm so excited to have our speakers here today to talk to you about non-point source pollution and this special topic and give you a chance to ask questions and really dive in a bit more to this topic, which the long version of the topic is non-point source pollution. It begins at home. So that's super exciting. And just a few bits of housekeeping. Like I said, this meeting is being recorded. So I will send out the recording to everyone who registered, and it will also go on our website and our YouTube page. So if you have to duck out for any reason, you'll get the recording, no biggie. Other things, if you want to, there's a poll out just asking kind of who you are so that we know who's in the group today. It seems like we've got a good mix of a bunch of different folks. So that's awesome. And so yeah, if you don't mind just putting out or filling out that poll. And if you want to introduce yourself in the chat box, feel free. I will also be watching the chat box for questions and things as our speakers give their presentations. So if you do have any questions that pop up during the presentations, feel free to put those in the chat box. Yeah, I think that's basically all of the housekeeping. So I'm going to turn it over to our two speakers to introduce themselves, and then Maura is going to go first with her presentation. So I will pass it to y'all.
I'll go first, and I can pass it to Sarah to say a welcome. My name is Maura Christian. I am with the Department of Environmental Quality, and I used to work on the Envirothon program, so I feel very happy to be back with a lot of familiar faces and names in the chat. So yeah, I'll be talking a bit about how DEQ works on the non-point source side of things with our water programs, and focus a bit more on the urban-suburban side. And I think Sarah, I'll pass it to Sarah, is going to focus a bit more on the agricultural side of non-point source pollution. So, Sarah.
Yeah, hi everybody. I'm Sara Bottenfield. I'm with the Virginia Department of Conservation and Recreation. I'm the Agricultural Incentives Program Manager there. So as Maura said, I'm going to focus a little more on agricultural land use and these kind of non-point source.
All right. Well, I can share my screen and get started. And I think we're both going to do about 20 minutes and leave plenty of time for questions. So I don't know if Byron, you want to monitor the chat. If it's appropriate to stop me, that's totally fine with me, or we can wait till the end and do any questions. I'm more than happy to answer anything that you have that would be helpful for learning about this special topic.
Sounds good. Thanks, Maura.
Yeah. Okay. All right. If you can't see me, just go ahead and holler at me, but I'll keep going. Like I said, my name is Maura Christian. My title
Maura,
with DEQ.
your screen popped up for a second and now it has gone away.
Rats. Let me try again. Thank you.
Mm-hmm.
One more time. All right. Am I still good?
You are good to go now.
Okay. I think I actually did click to end share screen, so that's funny, but my bad. My role with DEQ is the Chesapeake Bay Outreach Coordinator. So I work within our water division, specifically on programs within the Chesapeake Bay. I also work a bit with some state regulations on the Chesapeake Bay Preservation Act, which I've got a little slide on here to talk about later. But our role really is to coordinate a lot of federal efforts with the Chesapeake Bay program. So we work with other states in the Chesapeake Bay watershed, but I'm not going to focus so much on that work today. I'll do some more broad sharing about what non-point source pollution looks like and how that works professionally in my career. And yeah, I think I'm excited to be here with you all and see lots of familiar faces, like I already said. So the topics I was going to cover this afternoon deal with generally what is non-point source, what is point source pollution, but more in depth about what water quality monitoring does in terms of looking at non-point source pollution and some of those challenges that come with specifically monitoring for non-point sources of pollution. Big picture, kind of the role of how land use and land management plays a big role in the output of non-point source pollution. what's a total maximum daily load, or TMDL, as we say a lot in my world. And like I said, I'm going to end with some information about the Chesapeake Bay Preservation Act. So just to start off, I just have to share a little bit about what DEQ does with our water division. And I'm not going to talk about all of these links here. I more wanted to save this as a resource for you to go back and look to see if you have interest in researching more about specific work that goes on for wetlands, or some kind of grants that we have. So that's here as a resource for you. But in general, DEQ's role is to administer state laws and regulations to improve and protect Virginia's streams, rivers, bays, wetlands, and groundwater for aquatic life, human health, and other beneficial water uses. So really all aspects of water when it comes to the regulatory side of things. And we also do some more grants to offer programs to install projects like BMPs I'll talk about later. But I encourage you to go through these links if you have the time. It kind of demonstrates the wide array of programs and types of work that goes into non-point source pollution. It's a lot of different programs working together. And there's also a lot of career opportunities in this world. I have to plug that if you have interest in any kind of these topics here, I encourage you to do some research about what jobs you might work towards. There's an internship program for college students with DEQ that has a lot of opportunities for getting into permit writing and all sorts of type of work that you might not think about when it comes to environmental careers. So just to dive into the actual special topic here, to define a bit about what non-point source pollution is and what it isn't, I just threw some pictures on here from my photo database from DEQ that demonstrate pretty well what we're looking at for non-point source pollution in the suburban urban realm. But at its simplest form, non-point source pollution is water that picks up different types of sources of pollution, and that we can't quite determine where those sources come from at the end when they enter a body of water. So it's a lot of things that we can't necessarily determine where they come from. And they're not all chemical toxics that you think of. They can be natural sources too. So sediment, for example, is considered a pollutant that we monitor and try and prevent entering into our waterways. So natural and chemical sources can be non-point source pollution, and they're picked up by rain or snowmelt and moving over the land into the waterways. And that's where we kind of find the problems. And we know that when we continue to develop and we build more and more impervious surfaces, like you can see here, roadways, sidewalks, bus stops, buildings, all of that impervious surface leads to more runoff and picking up of more pollutants that are not absorbed into the water like they would naturally in a forest, for example. Some specific examples of non-point source pollution that we can see in our own backyards, the title of this year's special topic, can be fertilizers, even at your own property. Putting down excess fertilizer is considered non-point source pollution. Used household chemicals, paints, gasoline, oil. Pet waste is a big one that they teach kind of when you go through that meaningful watershed education experience when you're in elementary school. Pick up the poop. Leaves and debris that ends up in the streets, storm drains, sediment from construction sites, or just sediment that runs off a property that isn't properly, water isn't properly infiltrating into the ground. Failed or improperly managed septic systems. And I know Sarah's going to talk about the agricultural side of things, but animal manure, nutrient loss, pesticides, chemicals from those kind of types of lands, bacteria from livestock, and it also can come from the atmospheric deposition. So those are small examples of what types of non-point source pollution we can have. And in contrast, the term point source pollution is one that's a bit easier to define and to know what is point source, because you can point to where that source of pollution is coming from. So in my head, I think of it as more industrial sources. It's not always the case, but that's the most fresh to mind example. So for example, here's an industry factory of some kind that I'm sure has an outfall pipe that we can say that's a point source of pollution. It can also come from sewage treatment plants, channels, wells, vessels, so boats, stuff like that. And in the recent less than 2 months, we've had two really big examples of point source pollution that have made the news and are a hot topic right now. That was a sewage spill up on the Potomac River in the Maryland area, and a jet fuel spill down in the Norfolk area. So point source pollutions tend, when there's big problems, they tend to make the news. So I think most people on this call, especially the soil water district staff, know that non-point source pollution is a bad thing, but we might not necessarily know why other audiences would care about non-point source pollution, and that's a big part of my job. But DEQ is being able to communicate why other folks should care, and find what is meaningful to that group or individual, to get them to be invested in improving water quality. So I just put some examples here on the slide, but we talk about public understanding of non-point source pollution, and that can look like humans want to rely on waterways for recreation. They want to eat the local fish and wildlife and shellfish. That's a big part of the economy and why we care about water, is because we like fish and shellfish to eat, and that's a big economic value for communities. So when we talk about non-point source pollution and why it's a bad thing, frame it as it impacts the things you care about: your fish and your economy, public health. To be able to safely be in the water, drinking water is a big safety reason why folks care about reducing non-point source pollution. Cultural, historic value for waterways, that is a big connection for a lot of communities, is their local waterways, is for cultural reasons. And obviously, the habitat and wildlife is a huge component, but that's not something that everyone necessarily cares about. They should, but it's not always true. And for me in my work, it's important to communicate more than just the ecology part of it, more than just the science and regulations, but more, like I said, making the information about non-point source pollution relevant to the audience you're talking about. When I'm talking to local governments, it's how can you make sure they understand why a clean waterway is important to their community and their constituents when they have so many other problems going on that they have to deal with on a day-to-day basis. Homeowners and landowners might care more about non-point source pollution because of their property value. They want to make sure that if they have to do anything to reduce non-point source pollution, they might think about it more as, can they save money? Can they improve the value of their land? When we talk about some best management practices in a couple minutes, those are things to think about. Excuse me. Caring about letting their dogs be able to swim in the water safely. And let's see. Yeah, I'll leave that there. But I just think that's important to keep in the back of our head when we talk about these kind of things, is the different reasons why non-point source pollution is of interest to different audiences. The less kind of fun side of things, but I wanted to make sure I gave you as much information as I could that would be relevant for your special topic test and your oral presentation, is to talk a bit about the more science side of non-point source pollution and what water quality monitoring and programs are in place to look at non-point source pollution. I'll start with kind of this graphic, which is a good visual here on the slide, to demonstrate what we call Virginia's continuing planning process, or CPP. And it's when we talk about water quality and the whole program involved with monitoring and assessing water quality, whether that's a local stream or a pond or the entire Chesapeake Bay watershed, we have what we call a continuing planning process that sets certain water quality standards for the state. So they're, for each type of pollutant or impairment, there are standards we have to maintain and are working towards to keep water clean. And we achieve that process by monitoring for chemical, physical, and biological data. And I could spend a lot more time, and there's a lot of other experts that are not here that could talk about what goes into the chemical, physical, and biological monitoring to assess water quality data, but I just wanted to throw those words out for you as that might come up on your test, with the overall goal to limit the discharge of pollutants from point sources and non-point sources to promote and promoting the implementation of control programs and practices to mitigate water quality impacts from non-point sources. So when we're talking about water quality standards, the overarching goal is to obviously limit pollutants from non-point and point source pollutions, but a lot has to go into behind the scenes to make that happen. Like I said, the state adopts water quality standards. That's to protect the public health, enhance the quality of water, and serve the purpose of the Clean Water Act. I know the Clean Water Act came up a lot in your study resources. That's something I would certainly look into and research more after this call, or if you have questions, I'm happy to try and help. But the motivator behind a lot of the work we do, aside from caring and wanting our waters to be clean, is the Clean Water Act, and a lot of state requirements trickle down from that Clean Water Act. Another important word that's actually not on this slide I wanted to highlight, that is also in your study resources, that falls under the umbrella of the Clean Water Act and requirements that states have to follow to maintain our water quality standards, is that states are required to designate what we call designated uses for all of the types of water that we monitor and assess. A designated use, let's see. Each water body is designated for certain types of uses. So the term kind of naturally lends itself, but a water quality can be, or a water body can be designated for recreational uses such as swimming and boating, propagation and growth of fish, so game fish, wildlife, production of edible and marketable natural resources, fish and shellfish, and those designated uses that are, titled to each water body are communicated to the public for each waterway. Then that really helps inform down the line what criteria must be adopted to protect those designated uses as part of the Clean Water Act. So they're all these terms I'm talking about are interconnected, but I want to make sure you remember the Clean Water Act, designated uses, and all of this is an element that I'll talk about later, which has to do with our total maximum daily load, which is kind of like a pollution diet. So if there are issues with the waterway, we would set up a TMDL, or total maximum daily load, for those that don't meet those standards. A lot of words I just shared, but to go back a step, to kind of talk about another step of the process, and that's the first bullet here on this slide. That's talking about monitoring water bodies. That involves collecting chemical, physical, and biological data, like I mentioned, needed to assess the quality of states' waters and identify sources of pollution. That would look at things like dissolved oxygen, pH, temperature, bacteria, and nutrients. We also would use monitoring data to assess if a project that we install is effective in some way. Look at permit compliance, identify specific impairments of pollution, such as E. coli, track trends over time, respond to safety or public health emergencies, like the Potomac sewage spill, and work with other agencies like the Department of Health in these cases. A big challenge, and I realize I'm probably taking too much time, I need to speed up a little bit. A big challenge to monitoring specifically for non-point source pollution is the variability. When we're looking at a big waterway and we don't know where certain types of pollutants are coming from, you have to take a lot of samples to accurately and reliably capture a true pattern. There's a lot of different variables, such as flow patterns of water. Concentration can vary amongst the body of water and changes over time. So it's challenging to measure for non-point source pollution. And that's why it's important that we have widespread monitoring and assessment. I'm going to skip ahead just for time's sake and talk about another, I know, important part of your study resources that has to do with non-point source programs. So that's a part of the puzzle. Once a waterway has been identified as impaired, there's exceeding water quality standards, basically the federal government through the Environmental Protection Agency has a non-point source program that trickles down to the states and provides funding to implement best management practices, or BMPs, to bring that water body back to better standards, to meet the minimum water quality standards. So very much simplified that program, but I would research more the non-point source program, and that's what we call the Clean Water Act Section 319 funding. I believe I wrote this down because I knew I was going to get behind. Page 147 of your study resources talks about the non-point source program. I'm going to skip this graphic just for time's sake as well, and skip to solutions to addressing non-point source pollution. So we know non-point source pollution is a problem. There's a lot of waterways that do not quite meet our water quality standards or designated uses. So what can we do to improve those waterways? How can we bring them back up to standards and reduce the amount of pollutants that are impacting the health of wildlife, human health, etc.? On the side here, I put best management practices, or BMPs. That's a specific type of project that's designed to reduce pollutants that are generated or delivered from a source to a water body. Generally, they reduce erosion, increase infiltration of water on site, and better manage pollutants leaving a space. So that can look like a lot of different types of projects, but I would encourage you to look into the Virginia Conservation Assistance Program. They have a great manual that outlines a lot of different types of projects, such as rain gardens, using native plants, trees, certain types of permeable pavement, infiltration trenches. There's lots of specific project types that fall under the umbrella of a BMP. Similar in that vein is what we call low impact development. I think of this more as when you're planning an entire subdivision, smart development before something's already been installed. So I think a BMP is something that addresses a specific problem already existing. Low impact development in my head is more being proactive in designing something with the intent to reduce non-point source pollution from ever leaving to begin with. And there's on this slide some examples of some low impact development that I won't go into too much depth, but that's an important type of project that you should look up. And I also wanted to just plug that once construction has been done or it's underway, we have what's called erosion sediment control requirements or permits, and that basically controls non-point source pollution and regulates that when construction is underway. So that's after a new house is developed, erosion sediment control is something that is required during development and following with stormwater controls. Let's see. I'm going to skip to this just for time's sake, but I'm happy to go back to any specific items with questions once Sarah gets through her presentation. But I wanted to plug something that's specific to Virginia that I think would be really helpful for teams and students to know, maybe for your oral presentation scenario, possibly. And this has to do with the Chesapeake Bay Preservation Act. It is a Virginia-specific requirement in one of our major non-point source management programs. And we talked already about how land use decisions play a huge role in water quality and non-point source pollution. And this is one perfect example of that in action, really. The purpose of what we call the Bay Act for short is to protect and improve water quality in the Chesapeake Bay by requiring effective land use management practices during construction. So local governments have to require certain, or they have certain restrictions for new development and removing vegetation in areas that are most vulnerable to cause, non-point source pollution close to waterways. And there's a whole lot more I could say about this, but it's a non-point source pollution at its core. And you can see here in this map, I don't actually know where this is, but the areas in yellow are what we call resource protection areas. So usually that's wetlands, tidal bodies of water, perennial streams, et cetera, that are, the source of where water and land meet. And, if there is development or lack of vegetation there, non-point source pollution would be a lot more of a problem. So it's really a buffer to protect water bodies from non-point source pollution. We also have what's called resource management areas, which is 100 feet back generally from those resource protection areas. Let's see. I will leave that at that. It's a complicated program, but one that Virginia has in place that is required for most local governments that are east of Interstate 95. So 84 local governments on the eastern part of the Chesapeake Bay watershed have to require that when new development comes up. So if you're a landowner in those areas, it's a requirement you have to follow. That was all over the place, a lot of information, but I want to stop it there so Sarah has time to present, and I'm happy to answer any questions. Thank
Great.
you.
Thank you so much, Maura. I'm not seeing any questions in the chat right now, but as a reminder, feel free to leave those questions there. We'll get to them at the end for sure. And any questions we can answer in the meantime, we'll make sure to answer too. But Sarah, the floor is yours.
Great. Thank you.
Sarah, your mic is unfortunately sounding a bit funky again.
Okay. Let me see. Does that help at all?
It helped a little bit, yeah.
Okay. All right. I'll do my best to speak up. All right. Let me. I see my title slide. Okay. Perfect. So like Maura, I had a hard time condensing everything into a roughly 20-minute presentation. So I'm going to try and really keep this moving and leave plenty of time for questions. But I'm going to cover sort of an overview and just a brief introduction to some of our best management practices that are common, as well as just non-point source pollution and generally what that looks like on agricultural land uses. So I think we all are familiar with what non-point source pollution is. It's coming from diffuse sources across the landscape being carried by runoff into our water bodies. When we apply that to agricultural land use, the types of pollution we typically are looking at, especially when it comes to implementing BMPs, are nutrients from excess fertilizer, sediment from crop fields and from households, and nutrients and pathogens from livestock waste. Maura talked about the water quality monitoring and assessment that DEQ does, as well as TMDLs and TMDL implementation. I'm going to talk a little bit about more of an individual site level assessment of non-point source pollution, particularly with agriculture and BMP implementation. That's typically what we're dealing with. Oftentimes that's going to be a visual site assessment that may be in person in the field, or it could be looking at something like aerial photography. I have some examples, and this these visual examples I think really lend themselves to a presentation like this. But I do want to make sure folks know that not every type of pollution from agricultural source is going to be visible to you. But in addition to just a visual assessment of the site, potentially using something like aerial photography, we also often look at topographic maps, elevation profiles, the distance and the direction of the adjacent water bodies, because we want to make sure we know where the runoff from a particular field or a site is actually ending up as part of our assessment and our process about BMPs. So for some examples of what you might see on an agricultural site, we look at the photo on the left here. This is a crop field. It looks like this is taken in the winter, probably. If we look at the trees in the background, and we have nothing really growing on this field, and a few little green sprigs there in the foreground. But this appears to be a crop field where the row crop with cash crop was harvested in the late summer or the fall, and we now don't really have anything pouring on this field during weather. And we can see pretty clearly there is some sediment transport happening from this site. We have the gully that's starting to form. So we can pretty reliably say there is erosion happening in this field. And we may also be getting some nutrient transport as well. And if we look at the photo on the right, this is a photo from a livestock operation, cattle operation. And this is an area where the cattle are being brought into this one area to be fed. And then once they've eaten, they go back out to the other pasture areas and farm. And so the pile there in the center of the photo is manure. So the farmer is coming in, the cattle have all been here eating, he scrapes the manure up into his pile, but that pile is still just exposed to rainfall, snow, whatever, so precipitation that we have on the site. We also have all the cattle coming together in this concentrated group. It makes it basically impossible for vegetation to stay established in that area. And so in addition to the manure being there that could be transported by land, we also have a lot of soil exposed that can easily be picked up, transported, and become a source of sediment pollution as well. And then I wanted to show an example of what you might see if you're using aerial photography to look at potential agricultural sources of pollution. So this is just a screenshot that I grabbed from aerial photography. It is somewhere in Virginia, but I couldn't tell you where. But this is, what the site in the right-hand picture might look like if you saw it from the air. You can see these areas that don't have any vegetation. We can see just the soil is exposed, and the trails where the livestock are walking back and forth from those areas, compared to other parts of the pasture where there is grass and they're able to stay. So when we think about what BMPs or what solutions there might be to address some of these agricultural water pollution issues, there are many different types of pest management practices that are available. You might look at one, you might look at a suite of them. There is funding often available through both state and federal programs to support implementation of BMPs. The state funding program is the program that I manage. Similar programs are available through federal agencies, and these funding programs are participation in them is voluntary. Implementation of BMPs through those programs is voluntary, and the funding that is provided is commonly referred to as share, because the idea is that the farmer bears part of the cost of implementing the BMP, and then the other portion of the cost is made up by the funding from this program. So the cost is being shared between two entities. There are a lot of different things that you would want to consider when you're thinking about an appropriate BMP to address pollution. But as sort of a baseline, the BMP of course needs to address the pollution that's occurring, but it also has to be feasible for the farmer. It has to be something that can be incorporated into the operation in a way that is going to allow them to continue running their farm. I'm going to move into talking about some of the most common agricultural BMPs in Virginia. This is going to be just a very quick touch on a lot of these, and I do have some resources at the end that hopefully you guys need more detail. You can check some of those out. So starting with cropland BMPs, we have a wide variety of practices. You may see or hear of tillage practices. So farmers who have this no-till or some type of reduced foliage to help minimize soil erosion. BMPs like strip cropping, where fields are planted on the contour of the land, then to help minimize soil erosion. There are nutrient management BMPs, as well as cover crop BMPs. Just a little bit more about the nutrient
Sarah,
management.
your mic has gotten a little funky again.
Oh, I'm sorry.
You're good.
I'm trying to switch to a different. I'm on just a second.
While we wait for Sarah to get mics switched potentially, if anyone has any questions about any of these topics, go ahead and put them in the chat. Yeah.
Okay, I'm sorry about that. Byron, can you hear me?
This sounds good, yeah.
Okay, all right. Sorry about that.
You're good.
Okay, so nutrient management BMPs, these are going to be practices that target the rate, placement, and or timing of nitrogen and phosphorus applications. And the goal is to improve uptake by the plant, so that the nutrient is being applied at the time and in the quantity that the plant can actually maximize the usage of it and take of it, and to avoid over application. So trying to tailor the amount of fertilizer or nutrients that are applied, with the overall goal of just avoiding excess nutrients, excess fertilizer application that can then make its way into water bodies and become pollutant. And cover crops, this is probably one of the most common and maybe most familiar pest management practices. If you've ever driven by, a crop field in the winter and wondered why it's all green, that's because the farmer is most likely planting something with a cover crop. There are many, many different options for cover crop BMPs, depending on the season that they're being planted in, the species of cover crop that's being planted, what type of crop is in the field prior to the cover crop, and more. So lots of options, but the overall goal of cover crop BMPs is to establish vegetative cover on cropland, to reduce soil erosion and loss of nutrients from that field when it's not being used to grow. A couple of BMPs that apply to cropland as well as some other ag land uses. There are BMPs to plant cropland to long-term vegetation. So this establishes a grass or a legume cover on what was row crop land for a minimum of 5 years, and that provides reduced soil erosion compared to what we see with row crop use. There also are BMPs for cropland as well as for pasture land to actually convert that ag land use to forest. So planting trees on, typically that's going to be on marginal fields, so a field that is maybe doesn't have good soils, maybe it tends to be wet or it's shaded, something that makes it not super productive for the operation. A farmer can just plant trees on that field and convert the land use. As you can imagine, converting to a forest land use significantly reduces pollutants from whatever that pre-conversion land use was. And so soil erosion It may have been a nutrient application or livestock that was present in that pre-conversion land use. So significantly reduced soil use.
Sarah, I'm so sorry, but the mic is acting up again.
My gosh, I wonder if it's my, like my connection to the mic rather than the mic itself.
Yeah, you sound good right now, but every now and then it goes into periods where it gets all garbled. But we did have a question in the chat
Okay.
that is, what is pre-conversion erosion? So
Okay. So when I say the pre-conversion land use, that would be the crop, hay, or pasture use before it's converted to the forest for the long-term vegetation. So if it's a cropland before being, if it's in crop before being converted, you will have potentially sediment erosion, soil erosion, nutrient application, and phosphorus pollution. If there were livestock, there's pasture before being finished forest, and animal manure, putting source of that pollution. Hopefully that answers the question. If it doesn't, just put it. All right. Planting riparian buffers is one of our most beneficial BMPs in terms of pollution reduction benefits. So this involves establishing trees on the land adjacent to a stream at a minimum of a 35-foot width, but it can be wider from the edge of the stream bank to establish a forested land use right next to that stream. For maximum pollution reduction, that 35-foot width is kind of the magic number for something to be considered a true buffer. Buffers filter runoff from the adjacent land use, as well as providing lots of co-benefits in terms of things like wildlife habitat, like shade to the stream, low water temperatures, with lots of benefits from riparian buffers. Forested buffers specifically, the tree planting in the buffer can be done independently as a BMP, or it can be done in combination with any livestock stream exclusion. For the livestock stream exclusion practice, streams in a pasture are fenced to prevent livestock from accessing the stream. This eliminates direct deposition of waste to the stream, as well as the erosion that's caused to the stream bank because of that livestock traffic. It also creates a buffer adjacent to the stream that could be a forested buffer, like I just talked about, or it could just be an herbaceous buffer. Either way, it provides that filtration benefit, so that pollutants from the adjacent pasture have the opportunity to be filtered out before they reach the water. Because we're taking the livestock out of the stream with fence, these practices often include installation of watering troughs for the livestock to drink from as an alternative. Have some photos of what you might see with one of these livestock stream exclusion practices. So the top picture is shows some cows moving from one pasture to another, and they're actually crossing the stream. You can see the channel a little bit there in the center of the photo. So in this case, the stream flowed through the pasture, and since the cows were fenced out of the stream, this crossing was also installed so that they can move from one side of the pasture to the other without having to be in the stream. And then we have a picture of one of the watering troughs that you might see installed in the stream cycles. And then on the bottom right, just a picture of an excluded, the channel is kind of hidden in the middle part of the photo, but there's a channel there, and then excluding fencing on both sides, and then the password adjacent to it on each side. All right, the last category of BMPs I wanted to talk about are BMPs related to animal waste. And again, there are various options for these BMPs depending on the type of livestock, the number of livestock, how they're being managed on a particular operation. But generally speaking, these BMPs provide for the collection, storage, and or management of livestock waste. So they're preventing that waste from coming in contact with runoff and becoming social pollution. And they also allow that waste to be stored and then used appropriately. Whether that's used as fertilizer, maybe it's going to be taken off site. Most commonly, these practices are installed for poultry and for cattle, but lots of other types of livestock are applicable as well. And these practices do include addressing both animal manure as well as the normal mortality from poultry operations and other small ones. So a few more pictures. The one on this slide is a picture of a liquid manure pit. So storing this could be a dairy operation storing liquid manure in the concrete pit. And on this slide, we have a couple examples of cattle operations where you can see the cattle are being they're concentrated in areas where, again, we don't have any vegetation in place to hold some of the soil to provide a filtering effect. And we have getting lots of manure that can also become a source of pollution. And so in these cases, the BMP that was installed was a structure that allows the animals to be under concentrated and being fed. So manure can be collected there and can be stored also under roof for future use as a fertilizer. This photo is from a poultry operation. So the photo on the left, those piles are piles of poultry litter, which is the manure and the bedding that's removed from the poultry houses and the birds are grown inside of them. So in the picture on the left, those piles are outdoors, they're exposed to precipitation for runoff and become a source of pollution. So the BMP that was implemented here was to build a storage shed that keeps that litter under roof and able to be used appropriately on the future time. And then the photo on the right, that black cylinder inside the building is a drone composter. And so this is a poultry farm, and the poultry mortality that happens normally just as part of that operation can be processed using this composter that is implemented between solution. All right, so that was a very, very quick trip through BMP plan. There are many, many, many other BMPs that are available and can be implemented in agricultural plans. I wanted to just briefly mention a couple of other things to you all. One is that Virginia encourages farmers to adopt nutrient management plans. These are plans that are written by a certified plan writer to try and help farmers manage their nutrient application and avoid over application and excess nutrients becoming a source of pollution. In addition to the cost share that I mentioned, Virginia also provides state tax credits for BMPs, but also for the purchase of certain agricultural equipment that has a conservation value, a conservation use. So tillage equipment that is used for no-till or reduced tillage, as well as fertilizer and pesticide application equipment that allow a higher level of precision. Again, just with the intention to encourage practices that will reduce over application or other potential causes of pollution. My last slide is just some resources that you all may have already seen, but the first one is the Chesapeake Bay Program's BMP quick reference guide that includes both relevant and BMPs, and it has links to a lot of EPA documents that talk about how reductions are determined and other very technical information. I have some pages linked from the VCO website, general pages on agricultural incentives, management, and then link to the Virginia Posture Program manual, which is quite technical, but it does have details of all of the BMPs that Virginia has go for. And then the Federal Natural Resources Conservation Service, they are the main source of federal BMP cost share in Virginia. And so I would give them to some information out there. Thank you.
All right. Thank you so much. As everyone can kind of see, non-point source pollution is a super huge topic. So we understand that the students are having to learn quite a lot for this topic. So, I appreciate both of our speakers for putting so much great information into such short presentations. And I know that we didn't even begin to scratch the surface. So now is your time to ask any questions you may have. So please feel free to write questions in the chat. We will do our best to answer all of those questions. And as I mentioned in the chat, just as I'm waiting for things to come in, I'll grab the presentations from our speakers today so that we can send those out and make sure that y'all have access to all of the links and things that they shared. All right, any questions? I'm not seeing anything in the chat. Well, hopefully this was valuable training for you all, and I appreciate you all joining this afternoon. And another huge thank you to our speakers, Maura and Sara. They are both wealth of information source. Okay, so we did have a question. It just says source for BMPs for small organization maintenance shops. Can you expand upon that question a bit? Just so that, are you looking for a source that mentions those BMPs? Additional sources.
So
Sara,
brown,
yeah.
so would that be, I don't know, something like waste oil or something along those lines? Or are you thinking on the area that the property that you're working on?
We can maybe look into that a little more and see maybe what we can find.
Okay. Yeah, if you don't know, send it all over now.
Mm-hmm. Does anyone else have any questions for our speakers?
Quiet crew. That's okay.
We're nearing the end of the day, got the Tuesday sleepies. Okay, mowing, general maintenance, light build maintenance. Okay. Yeah, we can look into that.
Well said, BMP maintenance is a big part of the whole, maintenance is a huge component of the BMPs. If they're installed and not properly maintained, then they don't function and do the pollutant reduction benefits that they are supposed to do. So I don't know if that's what you're getting at, but
All right. Well, thank you again for everyone for joining and to our two speakers. I will be sure to send out this recording and all of the slides and everything. But yeah, thank you all for joining. I hope you have a good rest of your day.
thank you.
All right, I'm gonna